Today we are going to continue with our addition and subtraction, and we're going to have to utilize some of our more advanced factoring techniques. So let's start off with this first problem, and let's analyze these denominators. And what I'm seeing is that they are very, very similar to one another. So I think what I'm going to do is I am going to factor this one. I'm going to factor out a -1. And what I will get then is this, which is the same as that expression. So that leads me to know that my common denominator is going to be a -1 and a 3x minus 2. So then what I'm going to do is I'm going to, let me scratch that out so we don't look at that anymore. I am going to look at my denominators and see how they are different. So here is the first denominator, and I'm going to compare that to this denominator. And what I will notice is that they are the same. So this term stays right where it is. Now for the second fraction, I know I've got a 4x, but let's see if I'm going to need to change that. So let's look at the second denominator versus its new counterpart. And I notice there's a difference of a -1. So I think I am ready to get the final answer for this. So it looks like my denominator is going to be -3x minus 2. This up here is essentially -4x, isn't it? So it's a -3x up here, and I think we would be wise to cancel out those two negatives and say that is our most simplified answer. Let's go ahead and try another problem. So these are all very similar in the way that they're solved. Thinking we want to go ahead and factor out greatest common factor. So it won't matter which one you do that with, okay? It makes no difference whatsoever. So how about I factor out of here? So now that denominator is the same as that. So what I'm going to do is set up my problem. It might change the way this looks a little bit if you went about this by changing the other denominator, but it's essentially the same. So I'm going to need a -1 and a 5 minus 3x. Now, what might be interesting is the ALEKS program may expect us to actually write that in standard form with the x first. So I guess we'll have to cross that bridge when we come to it. So we'll put a 6 there, an 8 here, and let's see if we need to change anything here. Let's check out our denominators. Here's the original denominator. Here's the new denominator, and those are identical. So we're going to go ahead and leave the 6 just like it is. So now there's my old denominator, and there's the new. The only difference is a -1. So I think it's time to go ahead and try to write this in simplified form. So down here, I'm a little cautious about this, that the ALEKS program may not like that. So I think what I'm going to do is actually reverse this and put it into standard form. So I think I'm going to put -3x plus 5. But that all depends upon how well the software has been engineered. This is a -8, isn't it? However, we have a minus and a -8. So it's actually like adding 8. So 6 plus 8 is 14. And there you go. Now, there could be variations on the way this could be written. Like we could multiply that negative through the denominator. and get a 3x minus 5, which looks a little bit more simplified. I think I like that a little bit better. Let's take a look at this. What do you think we could do here? I think we need to do some factoring. What do you think? Looks like we got a slide divide method to work with here. So I'm going to work on this here for a moment. Oh, let's see here. How about 12 and 2? And I got to divide those by 3 since I slid the 3. Or eventually get down to our factors here. All right, so there's the factor that takes the place of this. And let's see, I see another common one right here. So I'm ready to write this again. All right, so here we go. So one common factor is this x plus 4. The other multiple, which is not in common, but we need to list it as 3x plus 2. Remember, you don't need to write that x plus 4 twice. It's actually doing too much. Might work against you a little bit later. The old numerators were 2 and 1. And let's see, let's analyze our denominators and do a comparison. So here's the original first denominator. Here's the new one, and it looks like those are the same. Not going to change my numerator. And there is the old, here's the new. It looks like it's different by a factor of 3x plus 2. Actually, it looks like that, right? So essentially 1 times 3x plus 2 is just 3x plus 2. I think we're ready to get our final answer. So we have our common denominator of x plus 4, 3x plus 2. Numerator would be 3x, and 2 is 4. There we go. All right, this will be our last question. Looks like we're going to need to do some more factoring. So I'm going to make some room for this. You're going to need to do a slide divide. So this will be x squared 2x minus 3. Got to factor that. I'm thinking 3 and negative 1. I slid a 3, divide by 3. X plus 1, 3x minus 1. Let me check out the other denominator. So maybe I'll put a box around that. That takes the place of that. Slide the 3, coincidentally. Let's try a little factoring here. We're going to need a negative 3, negative 1. Divide by 3. X minus 1, 3x minus 1. And that takes the place of that denominator. Look at that carefully. See if we can squeeze all of this in here. All right, so what do we have here? I can see we have an x plus 1. I think we have an x minus 1. And I think we have a 3x minus 1. All right, it's time to look at our numerators. We have a 2 and a 1. And let's see if we are going to need to alter those. So here is the original denominator. Here is the new version. What is different? It looks like an x minus 1. So I'm going to put that in parentheses. We'll need a distributive property eventually. Here's the original second denominator. Here's the new. What's different between those? I think an x plus 1. So I need that. So I don't, technically, we don't really even need that 1. So let's see here. The numerator will be 2x minus 2. We distribute. This will be x plus 1. All right, I think we're ready to get a final answer. So I think I could probably fit it all right here. So it's x plus 1, x minus 1, 3x minus 1, and 2x plus x is 3x. Negative 2 plus 1 is negative 1. And we should be good to go. And there you go. That's today's example problems for our lesson.